Let's jump then into the live demo. Okay, this is the demo environment. It's made of 3 different instances: the customer instance, the supply chain instance where all the vendors resides, and the auditor instance. All the 3 instances use the same machine for the AppNet processes, and I can see all the processes running on that machine. So let's start on the customer side and let's open the Hedera environment. There are 2 different components. The first one is the HNow connector that is managing the cryptographic key for the different participant. Each key has a name, the same that the participant, and the public key is visible and the private key is not visible, but you can see which one are actually hosted on that environment. Then you have the participants, and on that environment there are just the customer and there are a user that is used for the verification process. Okay, so this is the description of the um, Hedera application, and then you have the application that is built on top of the connector, in this case the distributed marketplace or e-procurement application. Let's start then the process as the customer, and let's create a service ask for the supplier network. So the service ask in that case is going to be something like 10 new production machines. So it's very simple, and I can save that ask locally, but when I hit submit to Hedera, this request is sent to the Hedera network and the state is submitted. But when the message goes to the network and come back through the mirror nodes, the state change to active, as you can see here. And you have the sequence number of the message marked in that field, and the party, which is the participant recognized by the Hedera DLT, is marked here as the customer in that case. If I refresh the message tab, I can see that there is one message that has defined the change of state that we just saw, and we open here the message and we see that each message is represented by the sequence unique number in the topic ID. You have a consensus date time of the network on which all the nodes agrees, the instance that submitted that, and all the cryptographic keys and signatures, and the state consistency field that represents the overall state of the ask and also bid table for every change of state in such a way that we are sure that all the participants are in agreement. Then the state now is of this message is processed, and you have all the details about the participant and the verification of the key that is of the signature that is very important, that tells that the message has been actually submitted by the owner of the key. So under the message is very important that you also get verification messages. So all the instances which are part of the AppNet send back the state consistency message, including the instance itself that originated the change of state, in such a way that you can verify that all the state consistency are in agreement. So everyone is agreeing on the same view of the reality when sequence number 23 was processed. So this is the message from a ServiceNow perspective. You can also open the message in the Hedera Explorer. We are using Kabuto here. And in Kabuto, you see similar information and you see the message payload. What is important here is that the message payload in the DLT is encrypted, and so no one actually knows the content of the message and the privacy is respected. A quick comment here for the most technical: this is not actually encryption, this is base64 encoding, but the mechanism to enable encryption here are very similar.